Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. I will continue talking about tahsili chemistry, and today I will talk about acid and base. So I will give you the information that you need to know about acid and base for tahsili. So first we will make a comparison between acid and base. So here acid taste sour, base taste bitter. Acid turns the litmus paper to red, where base turns the litmus paper to blue. Both are good conductors, and good conductors when they are solutions. So solutions for acid and base both are good conductors. Okay, but we know that acids will react with metals to produce hydrogen gas. Okay, so like HCl reacted with Zn to produce H2 plus ZnCl2. Okay, and here if we have an acid solution, it means that we have high concentration of hydrogen plus. If we have a base solution, so it means that we have high concentration of hydroxide ion. If we measure the pH for an acid, it will be less than 7. If we measure the pH for a base, it will be higher than 7. Okay, take an example. Let's take examples for acid like HCl, like H2SO4. Here it will be like NaOH and like KOH. And of course, we could have some materials that will be considered neutral, and the neutral, it means that the pH will be equal to 7. And also it means that it contains equal concentration of hydrogen ion and hydroxide ion. So it means inside the solution, if you have higher concentration of hydroxide ion, so this one will be a base. If you have higher concentration of hydrogen ion, so this will be an acid. If you have equal concentration of hydrogen and hydroxide, so it means this one will be a neutral. Okay, so next we need to know how to classify acid and base. Classification. And the classification of acid and base will be according to 3 models. The first one, which is Arrhenius. And here he could ask you to classify, or he could ask about the definition. Okay, so Arrhenius, according to Arrhenius, acid contains hydrogen plus and ionize in water to produce H plus. So it means like HCl, this one contains hydrogen, and when it's ionized or when dissolved in water, so it will give H plus plus Cl minus, so it will ionize to give H plus, so this one should be Arrhenius acid. Okay, also according to Arrhenius, the base, it will contain OH minus hydroxide ion, and when it dissolves in water, it will ionize to produce OH minus. Okay, it's like NaOH. So this substance has OH minus, and when dissolved in water, it will give you Na plus and OH minus. What is the problems with Arrhenius? We have only one problem with Arrhenius, that he didn't consider NH3 as a base, and NH3 is a base. Okay, so this is for Arrhenius. For Arrhenius, what is the problem? That he didn't decide actually what NH3 will be a base or not. He didn't consider it as a base because it doesn't contain OH, but actually NH3 is a base. The second model will be Bronsted and Lowry. And the Bronsted and Lowry define the acid and the base when they come into contact with another substance. It means that you should have here for Bronsted Lowry should have two substances because we will have interaction between them. The first one, which is an acid, the second one should be a base. How do we determine according to Bronsted Lowry? They said that the acid will be the substance that will give a proton. So it will be proton donor, and the proton is H+, which is hydrogen ion. So it means this substance will give an H+ to another one, so this will be considered an acid. And the substance that will accept or take or gain the hydrogen plus, this will be base. So this one will be proton acceptor. Okay, so we have two substances like HF plus H2O. Okay, how to think that one of them or how to determine of them will be an acid or not. So the one will be started with hydrogen, always this one will give an hydrogen. Okay, so this one will give an hydrogen and this one will be an acid according to Bronsted Lowry. And H2O will take an acid to take a hydrogen according to Bronsted Lowry, so it will be a base. So HF will convert it to F minus and H2O will convert it to H3O. And this H3O is called hydronium ion. And he asked about the definition of the hydronium ion. Hydronium ion is the ion resulted from the coordination between H+ and H2O. So it will be resulted by the coordination of hydrogen ion with H2O molecule. Okay, this will be called the hydronium ion. So here we have an acid. Why this one is acid? Because it lost one hydrogen. And how do we know that it will lose a hydrogen? Because it started with hydrogen. Okay, and H2O will be the base. We could take NH3, and this one is also a repeated question with H2O. Here NH3 will not have a hydrogen, it will not give a hydrogen to water. Actually, water H2O here will give hydrogen to NH3. So NH3 will be converted to NH4 plus and H2O will convert it to OH minus. In that case, H2O will be an acid and NH3 will be a base. So as we see here, the substance like H2O could sometimes act an acid and another time or sometimes also act as a base. And this one is called, according to Bronsted Lowry, is called amphoteric. So amphoteric substance is a substance that will act as an acid and as a base. So this one like H2O and like OH3. So here we have two amphoteric substances that you should know. The first one, which is H2O. This is the first amphoteric according to Bronsted Lowry, and the second amphoteric substance, which is AlOH3. Okay, we will continue as for Bronsted Lowry. Actually, when he asked about something. We know that HF will give a hydrogen to water, and this will convert it to F minus plus H3O. Here, the HF was an acid because it gave an hydrogen and it converted to F minus. Here, Bronsted Lowry said that the structure which will be resulted by the losing of hydrogen, which is from the acid, this will be called a conjugate base. So we have here pair of HF, which is an acid, and the conjugate base, this one will be the pair for the acid. And H2O is a base, and the structure resulting from accepting or taking an hydrogen, this will be a conjugate acid. So for each substance, we have like two phases, the phase with an acid, and if you have an acid, so we should have a phase which is a conjugate base, and if we have a base, so we'll be having a conjugate acid. It's like we have a dual phases for each one of them. So each structure will have two phases, the phase which is acting as an acid, and then when it acts as an acid, so it will convert it to another structure, this will conjugate base. And if it's a base like H2O, so it will have another structure which is H3O. So for each acid, we have a conjugate base, and for each base, we have a conjugate acid. How to write the conjugate base and the conjugate acid? Okay, if we have a substance and we want to write the conjugate acid without writing the equation from Bronsted and Lowry, actually what we need to do, we need to add hydrogen plus to the substance. So if I'm telling you that CO3 2 minus is a base, please write the conjugate acid for it. So it will be HCO3, and we have here 2 minus and plus 1, so it will be plus 1, minus 1. And also HS minus is an acid in the base, write the conjugate acid for it. So I will add H hydrogen, so it will be H2, as because we will adding H plus, so plus with minus, so we will end with 0. So to write the conjugate acid, we need to add a hydrogen plus. And to write the conjugate base, we need to remove hydrogen plus. So it means like H2SO4, we want to write the conjugate base for this one. So I will remove hydrogens. It will be 1 HSO4 and it will be HSO4 minus, because you remove 1 positive, so you will appear here 1 negative because it was 0. So 0 minus 1, so it will be minus 1. Okay, and here we could have like HCl. What is the conjugate base for this one? So it will be Cl minus, because we were removing the hydrogen. So he could ask you about writing the conjugate acid or the conjugate base for the substance. Also, we will classify substance or acid and base here according to the number for the hydrogen. So here, according to number of hydrogen or number of the proton inside the acid, we could have one acid with 1 proton, like this one, HCl. This will be called monoprotic. It means that it contains only 1 proton. And we could have H2SO4, so this one will call diprotic. And we could have H3BO4, so this one will be triprotic. Okay, so we could ask you again to classify acids according to the number of the hydrogen inside it. So this will be about Bronsted Lowry. The third model is Lewis. And we know that Lewis is mainly trying to examine the electron structure or the electron around the atoms inside the structure. So he talked about the atom and the electrons, and he said that any acid can take or gain electrons. So they will be electrons. Of course, they will take pair of electrons, except. And the base, they will be electrons donor. Okay, here is the opposite, because we said that for Bronsted Lowry, the acid will be the donor and the base will be the acceptor. You know, here according to Lewis, we're talking about electrons, so the acid will be the acceptor and the base will be the donor. Okay, so for acid to accept electrons, it means that you have deficiency of the electron. It means that you should have a positive sign. If you have only 1 atom. So like H plus, this one has a deficiency of electrons, so it will take electrons, so it would be an acid according to Lewis. Like, okay, this will be an acid here. And for base, it should have a negative sign, so it will have negative sign, negative charge, so it means that they have more electrons, so they can gain these, or they can donate these electrons, so they will be a base, like O2 minus, like F minus, so these like OH minus, so these all ions have an extra electron, so they can share their electrons. Okay, so if this one ion, if we don't have an ion, like we have a compound like BF3, how to classify this one in acid and base? Actually, here we need to draw Lewis structure. If you draw Lewis structure, so you will find the central atom like this one, have 3 bond, and they have lone pair. If they have lone pair, so they will be a base because they can share this lone pair with another atom. If they don't have a lone pair, they should be an acid. But also for an acid, they should have like A, this is the central atom, and they have only 6 electrons, so it means they need more too. So in that case, they will be an acid. So the acid, it means they will have only 6 electrons around them, so it means you need to gain 1 more pair of electrons, so they will be an acid. For a base, they will have 3 electrons around the central atom, so they will be a base because they can give these electrons to another atom like NH3, like H2O. We know that NH3 will have lone pair, so it means they can share the lone pair, so they will be a base according to Lewis. H2O, we have 2 lone pairs, so it means it's a base according to Lewis. For the acid, it may be having BF3, so we will having B and 3F. So it means they have only 3 bonds, they have 6 electrons, so they can gain more too, so it will be an acid according to Lewis. Okay, so what we need also to know more like this, we need to classify also or know acids and bases. We have something called acidic anhydride. And we have basic anhydride. So what is acidic anhydride and basic anhydride? Acidic anhydride, it's a substance that will react with H2O to produce acid. So this is a substance that will react with H2O to produce acid. And so from the definition also here for the basic, so it will react with H2O to produce base. So what substance could be considered as acidic anhydride and substance would consider a basic anhydride? Actually, for acidic anhydride, it's a non-metal oxide. And he asked about this point. He will ask you, if you dissolve CO2 with water, so what you will get, an acid or base? So this carbon is non-metal, so non-metal oxide should be dissolved in water, so we will have an acid. Okay, so for basic anhydride, so it will be metals oxide, like NaO. Okay, this one when dissolved in water, so it will give you a base. Okay, like CaO. So any metal oxide will dissolve in water will give you converted to hydroxide, so it will convert it to a base, while non-metal oxide will convert it to acid. Okay, now we will talk about some formulas. So here we will talk about the autoionization of water. So what is the autoionization of H2O? It means that H2O will ionize. One of them will give hydrogen to the other one, so it will convert it to hydronium ion and OH minus. And from this equation, we can have a formula which is Kw, and this one will be, because we have an equilibrium here, so this one will be the dissociation constant for water, it will equal to the concentration of the hydrogen ion times the concentration of the hydroxide ion. And both will be equal to 1 times 10 to the negative 14. So if you multiply the hydrogen ion with hydroxide ion, so you will be always equal to 1 times 10 to the negative 14. So if you have hydrogen ion more than hydroxide, it will be acidic. If you have hydroxide more than the hydrogen, it will be basic. So this is the first formula here. You can use this formula to calculate the concentration of any one of them. And as this formula give us a high number, which is numbers with 10 to the negative 10 or 14, so we will use another thing to also try to predict the acidity of the solution, which is the pH. And the pH is minus log the concentration of the hydrogen ion. And we will have also the pOH, which is minus log the concentration of the OH minus. And from this formula, we will have that pH plus pOH will equal to 14. So we have 4 formulas here. We can use any one of them to calculate maybe the pH or the concentration of any one of them. And we can also predict the acidity of the solution from the value for any one of them. So we will have 2 lines. The first one line will be for the concentration of the hydrogen, and the second line will be for the pH. The concentration of the hydrogen could be started from 0, and here it will be 1 times 10 to the negative 7, and here it will be 1 times 10 to the negative 14. If you between 0 and 1 times 10 to the negative 7, so this one will be acidic. If you more or between negative 7 and negative 14, this will be basic. Here for the pH, we'll have 0, we will have 7, we will have 14. If you again between 0 and 7, so this one will be acidic. If you are between 7 and 14, so this one will be basic. So what if you are at 7 or 10 to the negative 7, so you are neutral. Okay, so from this one, you can use it to identify the acidity of the solution. Also, we need to know a reaction which is called neutralization reaction. And this neutralization reaction is a reaction between acid and base. So we will have an acid plus base, they will react together, and by this reaction, we will have a salt and H2O. And salt means not the table salt, salt means ionic compound. Okay, so like KOH plus HCl, so it will give you KCl plus H2O. Okay, and this one is a double replacement. So he will ask you about the type of the neutralization reaction. It's a single replacement or double replacement or combustion or whatever. So it's a double replacement reaction. So, and we will use this one in a technique called a titration. And this titration is just a method we will use to determine the concentration of a solution. This solution could be acidic or basic with or by using solution with known concentration. So we will take an acid and base of unknown concentration, and we will use a titration with a known concentration. It also will be acid and base. So if you have the unknown like an acid, so we will take a base as known concentration and we will make the titration. And from this titration, we will determine the concentration of the unknown one. Okay, and the known concentration or the solution with the known concentration will be called the standard solution. And actually, this titration, we will have a technique like the burette. We will have a burette here, and we will have the acid. This is the acid of unknown concentration, and this is the base of the known concentration. And here we will add something called indicators, and these indicators will change the color when the pH of the solution change. So by this indicator, we will reach something called the endpoint, and the endpoint is the point where the indicator will change its color. So this will be the point where the indicator changes color. So it means that the titration is end and we need to stop adding more base. Okay, but the equivalence, we have another definition here, which is called equivalence. The equivalence point is the point where number of moles of acid will equal to number of moles of base. Okay, now we have only 2 points. Okay, the first one, which is salts. Salt is a ionic compound, as we said. And this ionic compound will have 2 ions, a positive and negative one. And it resulted from the reaction of base and acid. The positive one, it comes from the base. And the negative one, it comes from the acid. So the first thing here, he could ask you to write the type or determine the type of the acid, because we have 3 types here. The first one, which is the neutral one. And this is called neutral because it comes from strong acid plus a strong base. Okay, like NaCl. So this is the first ion, which is the positive, and this is the negative. Positive is always comes from the base. It means to write it. So I will add, this is a metal, so I will add hydroxide. So it will be NaOH, and NaOH is a strong base. And the Cl is coming from the acid, and to write the formula of the acid, we will add only hydrogen. So it will be HCl, and this is strong acid. So this one will be a neutral salt. The second one, it will be basic salt. And the basic salt, it means it comes from a strong base with weak acid. Okay, so like NaF, this one comes from NaOH, which is a strong base, and this comes from a weak acid like HF. And the third one, which is acidic salt, it means it comes from a strong acid plus weak base. Okay, so like here NH3, NH4Cl. This one comes from NH3. So if you have the base, which is the positive ion, have a nitrogen, so it comes from ammonia or NH3. So this will be always a base. And here the negative one, we have only add to hydrogen, and this one will be strong acid. So this one will be acidic solution. And we have a reaction here, which is called hydrolysis of salt. You need only to know the definition. So what is the hydrolysis of salt? Hydrolysis of salt, that the part of the salt will react with water. So which part? We will have two parts. We have the positive ion and we have the negative ion. Which one of them will react with water? Any one of them, according to which one will be coming from a weak base or a weak acid. If you are reacting the ion, the positive ion, so the positive ion will react with H2O and gain, or sorry, lose H plus to H2O. Okay, so this one will lose hydrogen positive or hydrogen ion to H2O. The negative ion will gain H plus from H2O. And this will be called the hydrolysis reaction. Okay, the last point, you need to know the definition of a buffer solution. So what is buffer solution? Buffer solution is a solution that resists the change in the pH. So this one will be resist the change of the pH when acid or base are added. So when you add an acid and base to solution, this solution will resist the change of the pH, and the pH will be stay almost the same. Okay, the buffer solution will be consist of weak acid with its conjugate base or weak base with its conjugate acid. Like HF with NaF, so this one is a weak acid, and the conjugate base, which is F minus. Or like NH3 with NH4Cl, this one is a weak base, and this one is a conjugate acid. Okay, this is all for acid and base. Let's try to solve more problems. I will put the link for this worksheet in the description so you can find it. Okay, number one, okay, I will not solve all the questions, so I will just go over it. Okay, so number one has a bitter taste. Okay, we know that the bitter taste is for a basic solution, so this one should be B. Hydrogen ion combine with water molecule. So if a hydrogen ion combine or coordinate with a water molecule, so we'll give you a hydronium ion. And the formula of the hydronium ion is H3O plus. In a basic solution, so we have basic solution, it means that we have higher concentration of hydroxide OH minus. So the OH minus should be higher concentration. So OH minus would be higher than H3, and H3O is equal to or equivalence to the H plus. So if you say H plus, it means that you say H3O. They are equivalent, okay? They are equivalent, sorry. For acidic solution, turn the litmus paper to, okay, it will be red. Which substance to change the litmus paper to from red to blue? If it will change it to blue, so it means that this one will be a base, and the base will be with hydroxide OH minus. In acidic solutions, the concentration of hydrogen ion will be larger, of course, or more than the concentration of the hydroxide ion. So it will be A. Because we are acidic, so the hydrogen will be more. According to Arrhenius, a substance that dissociates in water to produce hydrogen, because this one will be acidic, so it will dissociate with water to produce a hydrogen ion. Which of the following is not Arrhenius base? We said this point, and we said this one is very important. And H3 is a base, but it's not Arrhenius base because he didn't prove it. Okay. Then, according to Bronislaw, a hydrogen donor is an acid. The one will give a hydrogen, so it will be an acid. Okay, the conjugate base for H3O, H3O minus. So it means a conjugate base, so we need to remove a hydrogen. So I will remove hydrogen, and then I will move more plus. It means the minus will be increased by -2, so it will be A. The conjugate base for H3BO4. So I need again to remove one hydrogen, so it will be H2BO4 minus. According to Bronislaw, ammonia is in H3. If you reacted this one with H2O, so it will take hydrogen from H2O. So it will take hydrogen, it means this one will be a base. The conjugate acid for NH3, to write the conjugate acid, we need to add hydrogen. So I will add more hydrogen, so it will be NH4. Amphoteric substance like H2O and like AlOH alcohol 3. AlOH3. HCl it has only one hydrogen, so it will be monoprotic acid. Okay, phosphoric acid, which is H3BO4, so it has 3 hydrogens, so it will be triprotic acid. Lewis acid is, okay, Lewis is talking only about electrons, so we can take A or B, so A or B or be wrong. So we need to accept electron or donor. So the acid will accept for Lewis. Which of the following is Lewis acid? Lewis acid means it has a deficiency of electrons, so it can take electrons. So this one has more electrons, this one has more electrons, and also we know that NH3 has lone pair of electrons, so it will be BF3. Acidic anhydride is non-metal oxide. Non-metal oxide reacts with water, so it will be this one. In acidic solution, so the concentration of the hydrogen is acidic solution, so the concentration of the hydrogen will be between 0 and 10 to the -7. So it means it will be more than the hydroxide. So we can take this one, we can take this one. Okay, here, if the pH is more than 7, so it means this solution will be basic. Okay, and go back again for the scale. If the hydroxide equal to 10 to the -5, so what is the pH? So first I will convert the OH, hydroxide ion, to BOH. BOH will be minus log this value, so it will be 5. And you know that the minus log, it means that you need only to put this one as exponent as a number. So it will be 5. And we know that the pH plus BOH is equal to 14, so I will need only to subtract 14 minus 5, so it will be 9. And again, if the pH is equal to 6.5, so what is the BOH? We need to only subtract from 14, so it will be 7.5. If the BOH is equal to 3, so what is the concentration of the hydrogen? So from BOH, I could calculate the concentration of the hydroxide, which is equal to 10 to the negative of the BOH. So it means it will be 10 to the negative of 3. And again, from this one, I could calculate the concentration of the hydrogen because we have the formula that the concentration of the hydrogen times the concentration of the hydroxide equal to 1 times 10 to the -14. So it will be times -14 over here 10 to the negative 3. So it will be minus 11. 10 to the negative 11. If the concentration of the hydroxide is equal to 1 times 10 to the negative 9, so what is the pOH? We need to take the minus log for this one, logarithm, so it will be 9. Neutralization reaction is a double replacement. It's an reaction between an acid and base, and it's a double replacement reaction. Okay, so I will go. Okay, basic salt results from strong base and weak acid. So it will be strong base and weak acid B. The solution resists the change in the pH. This one will be buffer solution. The mixture of weak base and its conjugate acid, it's a buffer solution. Okay, by adding acid and base to the buffer solution, so the pH value will not change. Okay, so this is the end